Hi everyone, it's Nono here once more, and I want to welcome you to my live stream. If you're a newcomer, the Nono.MA live stream is a place that I reserve every week to cover things that have to do with creative coding, machine intelligence, creativity, and art and design, and many other things. We look at things that have to do with automation, efficiency, sketching, writing, podcasting, and many other things. And as I'll mention later, you can join our Discord server to get to know more people. Before we get started, as always, I'll ask you if you can hear me okay, if you can see me okay, and we'll get started. Also, a reminder is that you should go and maybe like the video if you want to support this project, support the videos that I'm putting up there and the live streams, and subscribe if you want to get notified when I go live or when I upload new videos. The Discord server is a community, so it's a sort of a chat application. If you haven't come through or come across Discord yet, you can join with an invite that we have at nono.ma/discord and join a lot of minds like yours probably that are interested in machine learning, coding, design, sketching, podcasting, writing, you name it. All right, so last week we saw live 27. So we covered React mainly with Next.js framework and TypeScript. And we took a look at ML5.js with TypeScript. That was a bit of a failure. But if you go to live 26 at nono.ma/live/26, you'll see an introduction that I did for ML5.js. And as I repeatedly have been mentioning lately, we're working on uploading all those videos as separate clips that you can consume better. Last week was 27. You can go to that video at nono.ma/live/27 or changing the number for any live stream. So far, we've gone through 27 and this is 28. And a reminder again, so I'm receiving some questions from you. I'm really glad that you're doing that. And I'll take some time to answer your questions on the podcast, hopefully. So gettingsimple.com/ask is a place where you can submit questions related to the topics that I cover on the Getting Simple podcast and to the interviews and to any other matters that we haven't covered yet, but you think would be a good fit to answer there. Go to gettingsimple.com/ask, click on the start recording button and record a voice note, a question, maybe introduce yourself and tell us who you are, and send it through your phone or your computer. You can also click on submit a written question there. Some of you have done that. That's okay as well. But if you feel comfortable, I'll encourage you to send a voice note instead of a written question note. All right. So what are we doing today? I put on the thumbnail of this video these three topics: TensorFlow.js, AI drawing, and Next.js. These are orientative topics. I don't always go and cover this exactly as I said, or sometimes we don't have time, sometimes we don't have the bandwidth to cover them, or sometimes it just fails. So TensorFlow.js, AI drawing, and Next.js. TensorFlow.js, I would like, we did some experiments a while ago with Lobe AI, and I never really managed to take advantage of the TensorFlow models that we were exporting from there. I know there have been some updates, so I want to take a look at how to export the model and maybe how to use it better. AI drawing. So the suggestive drawing project that you might have seen we have on previous live streams, this is something that I really want to recover, and it's going to take time, but we'll do it step by step. And then Next.js, just in case we can see a few more things there, continue looking and recording more tutorials. There is a new, so let me go quickly outside of this presentation. So let me see if I can click here and maybe go out or not, maybe. Oh, maybe this is not full screen. All right. So the new thing that I'm gonna show right now. So if you go to the YouTube channel, and this might play now. All right, that's good. So if you go to the YouTube channel that we have here, what you can see, and maybe this way you can see it better, we have Let me run this thing here. I'm going to show a playlist. So if you go to playlist, you can see on my last uploads, there are these videos with the blue covers, right? And that's what I want to show today. So this is the effort that I'm doing lately. So if you go to web here, so let's just, you're going to be able to find a playlist that is going to be featuring web development videos. So this is an effort I'm trying to do with all of the live streams that we do. Whatever topics we cover, I'm going to try to create separate playlists to gather the videos that are working around the same topic. So far, I think the Native one will be published tomorrow, but the other 3 are already public. And, you know, those are public from last week because we recorded them on the live stream, but this is a way in which, you know, I'm editing a bit more and making sure that we have the videos in a more condensed form. So this is 33 minutes that go over the build an Next.js app with React and TypeScript. And we don't, you know, you don't have to kind of look for that content inside of the live stream. All right, so let's save this and keep going. All right, let's leave the browser open here. All right, and I would like to also take some time to thank some of the people who are here with us today. So let me go back here. Hi, Sajeh. So I'm really glad that you keep coming and that you're watching again. I see that there's some other people online, so I'll invite you to introduce yourself or to tell us who you are, where you're connecting from, and what you're looking to learn from this today. All right, so let me make a quick introduction video. So, hi, or maybe let's put it like this. Hi everyone, it's Nono here, and this is an overview on how we can use TensorFlow.js with our machine learning models. I think on this video we're gonna take a look at how to export models that we have trained with Nono.AI into TensorFlow.js and hopefully use them with TypeScript. If we can do that, maybe we can add them into a React or a Next.js application to use the models locally on the browser instead of having to host them on the cloud. All right, so for people who are watching the video, we also have 2 other topics, as I said, AI drawing and Next.js. Not sure which ones we're going to be covering or not, but to follow up with the video, so let's code. All right, so let's code. And let's go here. All right, no break. Cool. Okay. And, you know, we have time now. So how's everyone doing? Is, you know, is the content that we're seeing lately something that you're interested in? It's a bit different to what we started doing, but, you know, hopefully we get some cool things. And Ricardo Cesar Rodriguez, hi to see you again, Ricardo. He sends us greetings from Brazil. If you're watching this video offline, you can also leave comments on the video comments because now people are texting or chatting on the live chat that will be closed if you watch it afterwards. All right, so let me take a look at this and remove the screen for just a second. I'm just gonna open Lobe and take a look at something. Right, so I'm gonna delete this thing. All right. Okay, great. Let's do this again then. Cool. So I'm gonna go and open, so let me center this thing. So I'm gonna go ahead and open Nono.AI. For those of you who don't know what Nono.AI is, Nono.AI is an application that tries to, oh wow, what happened here? All right. Right, so I'm gonna go ahead and, I don't know why, but Lobe is opening on the other window. So Nono.AI, for those of you who don't know what it is, it's an interface that is developed by Microsoft right now. It was a startup that was co-founded by Adam Menges, Mark Basinger, and Mike Matas. And it's a tool that tries to make deep learning accessible to everyone. Right now, they're tackling the problem of image classification, and we have past live stream videos that cover these topics as well. But today, we're going to focus on the ability of exporting TensorFlow.js models from something that we've trained here in Lobe. As a side note, really quickly, I'm going to go to the Getting Simple podcast. We had as a guest of one of our conversations, we have Adam Menges. So Adam Menges is, well, first of all, a wonderful human. And he introduces to the work that they were doing with Lobe at the time. Adam is not with Lobe anymore, but he was there on the steps of development and the development of the thing, and also during the Microsoft acquisition and the first beta launch. And there are detailed episode notes and a lot of links to many of the interesting things that at least interesting to me, that we talk about. I would definitely recommend you give it a listen if you're interested into machine learning and intuitive interfaces, and you want to get to know a bit more about the origins of Lobe. And these timestamps here will let you browse and skip to the parts that you're more interested in. So for example, here we have the early days of Lobe. All right, so with that, I'm going to close, and I will point you to, I don't really know, I think we had some notes. Let me see if I can point you guys to the live stream in which we covered the so live. We have the early day, not this one. Okay, so let's try to see which video is the one that we recorded Lobe. All right, Lobe. Yeah, so live number 4, training custom classifier with low TF live run when pix to pix. So we're gonna add that to the links for this live. So I'm gonna put here live for where we saw how to train classifier with Lobe AI. It's at the mass live/4. Great. And I do think that we cover Lobe later as well. Runway Lobe teachable machine. Okay, yeah, in live 13. Okay, lives in which we saw how to train and classifiers with Lobe. Right. Cool. All right. So that's there. So you guys have those links. And I think, there might be more, but we're going to keep going. So let's take a quick look. The objective here is to, we have a model or we have a data set first. So we have a data set. And let me actually try to do one thing. Let me just hide for a second and try to get my iPad connected here. All right, let me see. I'm not fully sure if I was able to do this last time. All right, let's see. I am here, and I have my iPad Pro. It's a bit old now, but it works pretty well. So let's try to let's see if we can use it with Sidecar, I think it's called. And for the people who are online right now, feel free to ask any questions or comment or let me know what you'd like to see today. Sidecar. Okay, so sidecar. So here, another practice that I've been following on previous lives to trying to note down the things that we do on the live stream as I do it. So later on, we know which videos maybe could be exported out to different clips. So I'm gonna go ahead and do that. And have it here. Okay. All right. So this is live 20. What is it? So okay, this is like 28. So topics, we have TensorFlow JS. We're gonna see sidecar with iPad now. Maybe we see other things later. All right, so I'll leave this here. Show sidebar, select device, Nono's iPad, and let's see what we can do here. Yeah, I'm not sure how I can. Oh, okay. I'm not sure how I can bring my. Right, so let's see, we're connected here. Nono's iPad, separate display. All right, so maybe I can, I should have tried this before, but because this is live, it's okay. So let's see. Right, so you see what I'm doing. I'm gonna hide myself on the live stream and show this thing live. So what we're gonna try to do is add a new display capture, add existing. So this is gonna be display, sidecar, iPad, or maybe just iPad. And we're gonna click on OK. We have 3 screens, 1, 2, 0. Right, 0 is this one. What about this one? Yeah, I'm not sure if we can capture the screen of the iPad through OBS. Maybe not. All right, I think I might have to fall back to something else. Right, so this failed. This definitely failed. So let's just remove this from here. Yes. And I'm gonna take this out so you don't get confused. Enable double tap on Apple Pencil. Let's try connect to LG HDR 4K. All right, let's try that one. Don't really understand. All right. Okay, mission failed. Probably shouldn't do that live. So let's disconnect from the iPad then and go back to normal. So I'm here again. Gotta do that. And I'm just gonna go for a plug. So I'm just gonna go for a really let's just try to plug it with a quick plug. All right. Okay, so we'll try that again in a second. So I can explain a bit what it's gonna, what's going on. But you can hear me back, so ignore that I tried to do that. I'm gonna try to plug it later, but let's try to make this quicker. So Nono.AI, we have some experiments here that we've done on previous live streams. So we can see here we did a few other tests, and here we have experiment 2, which I think was me trying to categorize sketches that were not square in this case, right? There were some that were square. I thought that the majority would be square, but it doesn't seem like these ones are. So let's see experiment 2.1. All right, we do have actually a data set that is square. So maybe, maybe we can do the entire round trip and train now. Right, so let's take a look here at one of the questions that are asked on the live stream, so on the chat, because I really like to take advantage of user interaction here. So this is something that is high priority for me. And to suppose I want to make, all right, so let's just copy literally what Ricardo is saying and try to comment on it. So this is here, and the follow-up is right here. And this is and if you're okay with that, I'll post your thumbnail here. Is that okay? Hopefully it is. If not, let me know. All right, this is a long question, but that's what it is. Can you guys hear me okay? So just to confirm that I'm not talking out in the wild. And of course I'll go to the right. Okay. All right. Yeah. All right. So this is a question. I'm going to record an intro and then we'll talk about it. And you can keep talking on the chat. That's good to have the conversation. Hi everyone, it's Nono here, and today we're going to discuss a question from the live stream by Ricardo Cesar Rodriguez from Brazil. The question reads, I've seen on Loeb's GitHub page some complementary applications such as image tools and Android Bootstrap, but since these classification tasks run on GPU, how will it run on a mobile app? Suppose I want to make an architectural style recognition mobile app. Would I have to keep it running on a PC and pass it through an API to make it work on Android or iOS app? So the question or the answer, the short answer is no. You don't have to have the computer working and then talk to it through an API, right? The API on the computer lets you test it, but it's not meant, so the API on the computer lets you test a model from another application, right? From a web application that is making requests, and from any local application that can make web requests to that. And it's a way to test it, or maybe to prototype, or maybe even to have systems work with that on your computer or on the local network. But when you're saying here that the application or the model needs a GPU, Nono.AI actually lets you train and then export the model to many different formats that can run natively on devices and mobiles. For example, TensorFlow Lite is optimized to run on Android devices and iOS devices, and TensorFlow Lite actually makes use of the mobile GPU, and it's runs faster many times on mobile device like an iPad Pro or something than on some other computers. because it has, TensorFlow Lite is optimized to work on those embedded devices and has better access to that GPU, right? So if you want to make an architectural style recognition mobile app, that is, it might be a bit challenging because, well, if it's a recognition, and with recognition you mean classification, you can do it with Lobe. And some of those templates that you mentioned, like image tools and the Android Bootstrap or iOS Bootstrap, they would allow you to run those models on your device using GPU. If it's a classification model, you can do it with Lobe. But if it's a different, let's say TensorFlow architectural model, and I'm saying architecture as in software architecture, right? Like the architecture of the actual neural network and the code of the machine learning model, not the architecture as in buildings. If your model is complex and has custom operations, you might find that when you try to export it to TensorFlow Lite, some operations might not be available and it might be hard. But for some models that are sort of standard or that use widely supported operations, you're going to be able to export it and then run it on an embedded device. That's something I would like to do, and they do have now. If we get out of this slide for a second, we can go to a new tab and go to, I think it should be at GitHub. I don't know if it's Lobe or if it's under Microsoft now, but yeah, they do have, so Lobe has the GitHub organization reserved with their brand name, and these bootstraps, this is what Ricardo is referring to. So we have here the word bootstrap, right? Image tool and bootstrap, Android Bootstrap. We can take a look at some of those if we go here and look at the web bootstrap, for instance, right? This is a boilerplate or like a schema of the application or how to build an application for the web that can, with React, TypeScript, and TensorFlow.js, that can classify your drawings. And this might be something that we could try on our, on the live stream, because it seems like here we already have the components that are required to run TensorFlow.js model and specifically exported from Lobe. And that's actually, a great idea. So we're going to do that now. And lastly, here you also have Lobe.NET. So you can run your models exported from Lobe in C# Android Bootstrap that lets you run your models in an Android device. So you will export, and you have here the instructions. So it seems like there might be some things that you need to do, but at the end of the day, you export that TensorFlow TF Lite model from Lobe, and that's it. And we can see how to export it now. So let me just quickly look lastly at so Lobe Python to run your models inside of a Python environment, and iOS Bootstrap. This is one that I also want to try. So this would be a starter application for using Lobe models inside of iOS or any other TensorFlow models that are compatible with this code. You might have to adjust it a bit, but this is, we can export to ML model. So probably not, we don't need to export to TF Lite and do that. And all these are all open source projects, so they might simplify a lot the work that you have to do to get your model into an embedded mobile device. All right, so that I hope answers your question, Ricardo, because you're live. Maybe you can reply back and we can continue the conversation. Thanks so much for the question, and I will invite anyone who's watching this offline to join the live streams on Thursday afternoons or Thursday midday if you're in the US or in the Americas, and maybe also ask some questions live and propose any conversation topics that you might be interested in. Okay, so thanks a lot for watching, and I'll see you next time. All right, so this is like a video presentation slide, so we're not finishing now. I'm just gonna continue here, but I hope that answers Ricardo's question. I'm gonna keep going, and I want to take some time also to say hi to Mamadou Kali. So nice to see you around, and yeah, so it's nice to see some familiar faces on the live stream again. All right, so let's keep going. So I was going to look, before Ricardo asked the question, I was going to go to the folder of some of the other live streams where we had a data set with, I think it was around here, right? Maybe, yeah, okay. So this data set is a lot more consistent. I'm not sure why we exported it so small. Maybe because maybe because we wanted to use it with Teachable Machine and not with I blanked out. With Teachable Machine and not with Lobe. Lobe accepts more image, like greater image resolution, and really quickly. So we're getting, we're gonna a bit slow today, but that's okay. So what we're gonna do now, we're going to get an updated list of my sketches. So let me see if I can get this. All right, so here we're simply getting we're running a command, and I'm going to go to the left now. So here we're running a command to save an XML URL into a file. So we're going to save it into the desktop, right? So XML, and that's it. So now we can edit that file with Visual Studio Code. So we're just going to get all the URLs of the images on my blog, and we're going to batch download them really quickly. So this is not going to take any time. So we have all of these square images here. So from here, I'm going to get all the URLs that have this part. So I'm going to select those. With some trickery here on the text editor, we're going to remove the beginning of them. And we need to fix these things. So we need to replace these amps with an actual ampersand, and I think that should work as URL. So we just need to replace and remove those things at the end. And with all of this, so I might be able to simply open one of those images and then see them here. All right. So now what we're going to do, we are going to, if I had that image, I could download it with curl. And to do that, I will do something like this and then specify. So do something like this and then specify where to save them. So for example, this could be like daisy.jpg, right? Yeah, I think so. So that's now here. And I have the image, right? So we're just gonna do that with all of the images. So we're gonna go into, so we just need to get the name of the images. So this part here, and we run curl on front of it. And then at the end, we put output and that name. All right, so also to have some input of what we're doing, we could also run, and I don't know why, but this was failing a while ago. So downloading and then the name of the image. Let's try this with a few so we don't run all of these commands. And so echo, we will have to actually put that above of the image. All right, so with all of that, and hello Bea, I also see that Bea has joined us. And okay, so now here we can open our terminal, and I can go to the desktop, make a folder that is going to be called 28 for today's live stream, make a directory that's going to be sketches, and then inside of sketches, that is, as you can see here, an empty folder, and I'm gonna put that right here. We're gonna see now that if we paste this command, maybe it doesn't work. Yeah, I remember something weird happening with oh, okay, yeah, so sorry for that. We have this thing here, but we need to put a thing here. All right, let's try this again. Parse error. Why? Oh, here, this. Right, let's just try to. All right, so I'm gonna remove the echo lines here, and I'm gonna put, oh wow, okay. I'll explain what's going on right now. And okay, fingers crossed, this works. Error. All right, let me remove all the echoes, and let's just go to that. Error writing body. What is going on? Oh, okay, so this shouldn't be here. Output, sketch. All right, so it seems like this is now working. So we're downloading the images actually. So just to try it to see if this works, I'm gonna go and put here this. All right, let's see, does this work? I said this was not gonna take any time, but it is taking time. Okay, that works. So let's see now, curl, silent, download. S, okay, silent. So we just need to add output and then put the silent flag, and hopefully that makes it work. All right, cool. So now I'm just gonna paste the whole thing. I'm gonna open the folder. So we have 3 sketches now here, and I'm just gonna run this big command. Boom. Oh, what's going on? All right, we'll get some of them. I don't know if we're gonna get all of them properly, but we're getting them. Great. So this is now downloading, and we're gonna train an algorithm in Lobe. The only thing I didn't do is that we need to separate them into some sort of classes, right? And last time what I did is separate black and white and color. So I guess we could do that while this is happening. So we'll do color, and we'll do black or monochrome. Yeah, black. All right, so I'm gonna go ahead and start doing that. So these are black and white. Ah. Right, maybe easier this way. Right, dataset preparation. This always takes more time than you thought. All right, so black, black, black. This one's color. All right, and this is color, color, color. All right, yeah, and it seems like the last one couldn't be downloaded, but that's okay. So I guess everything that's not color, we don't really need to label, but let's just take out all the color ones. All right, cool, awesome. That, this, that. All right, so we are, this doesn't have any color, but sort of has some shading inside, but we'll leave it out. That one, that one. All right, so these ones are black and white. So now we have our data set here. And we do have, we're gonna save this file, but maybe just as a bash script, download sketches, and we'll put them here. That's something we could put. And yeah, so now we're gonna make a new experiment. So this is new project. This is gonna be sketches live 28, and we don't have any labels, so maybe color, so black and white, black, I don't know if you'll get it, black and white, and then color. So we can, in Lobe, we can actually grab these two folders and drag them, and then it will ask us, would you like Lobe to use the folder names to automatically label your images? And then we say label using folder image, so folder name, import, and now we have, the black and white images and the color images in separate categories. We have 44 black and white, and we have 50 colored images. So right now there is something that happens is that this is training already, right? So Lobe is training on the background. And as I've experienced before, these might take some resources up from my computer and make it slow down and not make it work great, right? So what I'm gonna do is I might, take a break to make sure that, I'm not talking and everything's speeding down. But, you tell me also if you can see me okay or not. And as you can see, all of these images are labeled already. I could click here and change the label if something has been mislabeled by me. And we can see here the training process. So right now we already have a classifier being trained, and it's classifying correctly all of the images above, and it's classifying incorrectly all of the images below, right? And I think the bar tells you how wrong it is for each of the images. I'm not sure this is super wrong. It really thinks it's a color image, and others are like not so erroring, right? All right, and you can also see the little chart here, images black and white color, and yeah, I don't know how long this will take to train, but I'm gonna take a really quick break. I'll be back. I'm gonna zoom into this piece of training feedback so we can see, and I'll be back really soon. Okay, I'm back now. So this is already trained, and you can see that there are many images that are giving us an error. This is not great. You know, and I don't know if we can do anything, if there's anything that we can do. Training, I mean, it says training because I changed something, but I didn't really train anything. And oh, not sure. Yeah, and this retrained, but all right. So this actually, I'm not sure what's happened, but it actually retrained once more, and we now have a model that seems to be a lot more performant. It's only confusing these two drawings, right? So we can say this is black and white, and this is definitely color. And this is going to try to retrain. I don't really know what it does, but before it did retrain, and we got better results. All right, so let me know, you know, if you're following or if you have any questions so far. So what we've seen is Nono.AI, how to, you know, we manually prepare a data set with some sketches. It's not the best data set, I have to say, to do something like this, but we could think of other tasks if you're interested. Something that that I discussed with Michael Lustig, that he wanted to do some experiments training a screenshot classifier, and I'd be really curious to see if those are, you know, if that's something that works well. So we could definitely try that in this live stream as well. So we could say, for well, maybe let's hold on into building that data set for later, but now we can say use it. We can use it from right. All right, let's make a quick recap. So we'll use the model and then try to go back and understand what's happened. I'm gonna go to the web. I'm gonna go online, and I'm gonna look for sketches, live sketches. I don't know what will show up here. Maybe urban sketches. That's probably more the style that I'm trying to look for, right? And we could get this one, right, and just save some images to our desktop. And as I said before, what we're trying to see is if our classifier can recognize some of those artworks as black and white or as having color. And I'm not sure what's gonna happen. All right, and there might be factors that the model is learning that we can't manage to understand that are there. So let's put these images in here. So we have 4 images to drag and drop, and let's try it. So let's put this one here and see what happens. Right, color. That's wrong. I don't really know what that means, but color, that's okay. Might be telling us that everything's color. Black and white, right? Cool. And this is color, awesome. Nice. So, you know, it's not performing super well, but I guess that we can improve it by drag and dropping more images, right? So we're training all right, so black and white, awesome. Awesome. Yeah, Ricardo, that might be the case. I thought at least on previous versions you had to choose, right, to optimize for accuracy or speed, but it might be true that it's training for speed first to have a model and let you interact with it while it trains a more accurate model. If you go to, for those of you who don't know, because it seems like Ricardo already knows a fair bit, you could change from here, right? And we could select to optimize for speed instead of accuracy. And yeah, thanks for the comment, Ricardo, a lot, and that's really helpful. All right, so now we still have some images that are misclassified, but you know, they're not they're not new, they're from before, right? Black and white. All right, so that's black and white. What about this thing? That's black and white. What about this thing? That's black and white. Cool. Anything else? Let's try to take a look. So if we grab, do I have more sketches that are not there? Let's try something else. Right, so it seems like the model retrained again, and we can see the results. All right, so let's get one more. Black and white. Okay, I mean, it seems it works fairly decently. There are some things there that might not be working the best, but you know, they're there. So if we hover here on export, or we go to file and look at that, so we were here before on images, so now we go to export. Help me choose might give you some information on all the different types of exports that you can do, and how to load the models, and how to do all the things. Create an API for flexibility. This is to answer your question before, Roberto. So we have here that creating a REST API is one of the most versatile ways to hook up apps to use your model. You can call your model as a service from other products, deploy to a variety of cloud providers, or even run on your own computer or device like a Raspberry Pi. To prototype or experiment with using an API, check out Lobe Connect. To set up yourself to run in any location, check out REST server for an example of using Python and Flask with deployment instructions. All right, yeah, so Flask allows you to serve the model, as we've seen in other videos with Runway ML. You could set up your model in DigitalOcean, so a model that you've trained and are serving this way, and you could serve it from a web port, and any application, even mobile applications or web applications, could use it. So I guess if we go to the Web Bootstrap project, so if we, now what I'm gonna do is that I'm gonna keep those as Google Images data set, right? That these are things that we grabbed from the internet. It's good to have those as reference to know what your model contains and what copyright, right? What you use to train it. And here, so this is a Web Bootstrap, and was looking for the Flask server. Right, so bootstrap your low machine learning model with our REST API starter project. This is something that we could also try. So this is to Python app will serve locally, but we could do that on a remote server and set it to be working on a web app. So we could set that in DigitalOcean. So we have a really in-depth video on DigitalOcean that is live. Oh, it doesn't show up here anymore. Yeah, so that's live 19. We really saw an in-depth introduction to DigitalOcean, and I think there are some hints there on how to set that up. But if we looked at, so this is TF model here, Swagger API. So this defines the API of the service that we're going to put. So we have the predict route. This is the way to predict, and probably the app Pi has the Flask server, which, as you can see, is pretty easy. They used TF model helper. Skeleton code showing how to load and run TensorFlow, say model export package from Lobe. Cool. Awesome. Yeah, they do provide a bunch of code for you to not have to reinvent the wheel. All right, so what do we have here? We have Lobe Connect, host your model locally in Lobe. This probably uses that Flask code behind the scenes or some other way of serving the model. And, you know, we have the route here. We could predict. This might give us an error because we're not method not implemented. All right, because this is, we need to make a post request. And we do have so what videos did I mention before? 4 and 13. So we do have code already to do that. So live, open. Yeah, so if we go to 13 maybe. Nope, 4. TF-Lite2, say model example, TF-Lite Python. Yeah, I'm not sure if we have that. Love request, cool. Yeah, so we do have this here. So we have an example in folder 4. So 004 love request. Let's open that. So we have an example, and Ricardo, I guess you've done this already, but this is a way in which we can make requests to our black and white model from TypeScript code. So we can take a look at, let's go into love request and open that folder instead. Right, so we have this file. We can open a terminal window. Allow, right? I'm gonna do npm install. A bit risky while live streaming. All right, that was fine. And our URL probably is not the same, has a different unique ID. So I'm just gonna update this, port changed. And we import super agent. We have an image here as base 64, which probably, so how was this? Data base 64 PNG, maybe? Base 64 to decode. I never remember how to do these things. Data PNG base 64, maybe that. Image PNG. Nope. All right, what is this? Well, don't remember. Base, define an input, base 64 image pv copy with 2 obvious 0. Did I do this? Maybe I did do this. All right, so we're just gonna run this command, and we would open the folder on the desktop. So with the sketches, so for example, we just get the URL for one of these ones. So let's actually go to this one. So we go to this folder, and we do base 64, this image, pv copy, and we can copy this thing. What do we get here? All right. Cool. So this should work. That's the image that we have there. All right. Let's see if this works out of the box. And we do node index.ts. Oh, to learn ES model, ts node index.ts. All right, once more, up, once more. Da-da-da. All right, awesome. So we've sent our request, and I cannot post. Close. All right, let's take a look at the code again. So we are sending this to this URL. We're sending a payload, and maybe this changed. So we post body method. So payload method post headers content type application JSON payload body image. So no inputs. Let's take a look at Node.js. Image. All right, so I guess the payload is now only image. Well, let's try that. And cannot read property labels of undefined. Okay, so let's do res body. Yeah, so it seems this is a bit old. So, all right, so now that works. Cool. So now we can see that it's telling us that this image here is black and white, and it doesn't think that it's color. So we now have predictions instead of output. So we have predictions, and then we have two predictions, and we can, yeah, I guess we can just print that. Cool. All right, so this is the top one with more confidence, and I guess we could, let's take a look at this example. Base64 string, encoding base64, fs read file sync. All right, so yeah, that's good as well. So we can provide the path on the code instead of having to do it manually. So let's update this code example. So we can import as fs from fs. Do we have fs here? We might not have it. Let's try it. Yeah, we do have fs. So what we could do is that we could, instead of getting the file, so this base64 encoding manually, we could get it from here. So image as base64, fs, read file sync, and here encoding base64, and then file path or image path. So columns image path equals, and then here we'll have to put an input. So for now, let's just try the same one. So let's try the same, this one here. Right, let's try. Great, awesome. So that's working. So we behind. All right, so we're gonna leave this here. Read an input image and serialize as base64 with fs. We put the payload there, and we do that prediction. All right, so now we could easily get another image, so path. So for example, if we go to the desktop, 28, Google Images, so we can get the path, this one that said there was color. We put that path here, and we execute this command again. Right, so for that image, that is color image, we're getting color. All right, so this is just locally making a request to the local connect mode. So we've seen that first one and we updated this example. So we're gonna add index.ts and then the package JSON. And I'm gonna comment here. So this is livestream 28, update, lobe, request, low connect, request, TypeScript request sample. All right, we push, and so just do this here, and we just push, and that should be, that code should be now live here. So these two are updated, and you have that one there. Awesome. So let's take a look here. Awesome. So I put that on the Discord server. Awesome. So let's take a look at what we were going to take a look. So if you go now to low once again, maybe let's close this. We go to low and we have many different options. So we have the option to do this. So through an API, use your model in a Python app or a web app. But here we have these 3 starter projects. So we can, these are on GitHub. So we can click here and we'll get the same page that we were seeing before. We have these 4 templates here. And then model files. Apart from this lobe connect option that I don't see anywhere else, right? Like that might be, if we go, yeah, that's only here, connect. There are like many export options here. It's TensorFlow, ONNX, TensorFlow.js, CoreML, and TensorFlow Lite. TensorFlow Lite is the format that, as we mentioned before, you would run on Android, CoreML on iOS, TensorFlow.js on the web. ONNX for universal apps means it's cross-platform. I think you can port your models there, and then these to use in a Python app. So if we export this, we'll get what's called a saved model file. Export or optimize and export. We don't want to spend too much time, so we're just going to export this one. And what we're going to take a look at is the TensorFlow.js one. That's the one that we were going to take a look at initially in TypeScript. All right, so we've taken a look as well today at creating a classification, sketches, dataset, color, black and white, training, classifier with lobe, request predictions from lobe connect REST API with TypeScript, and now we're seeing export lobe models to TensorFlow Lite and TensorFlow.js. All right, cool. Let's keep going. So I have here, this is my model now. So, that's too big. So we have here the files of this model. So we have the model itself, the signature, the labels, variables, an example. So the file that tends to be big is the variables data, right? The model, regardless, I believe the model, regardless of how much information you train with or how big it is, this file is constant to the architecture of the model, I believe, and we can double click here to open with Netron to visualize that. The signature.json file, this defines the names of our inputs, the name of our experiment, and other things. So I can zoom into here so you can see, we see sketches live 28. The confidences, we see that we have two floats. One is going to be color and the other one black and white. Those are the labels and some other things, right? That's a signature for TensorFlow to know how to load the model. We have large model detected. Yes. Let's see if it doesn't crash. The labels, black and white and color, just two. And variables, TF example. Again, a really thorough example on how the code that we need to load our model with Python and make predictions right off the bat. This is really cool. This is really easy. And the requirements, in case we want to install, create an environment to run this model, still using TensorFlow 1.15. And the README, a lot of explanation on how to do that with a Python virtual environment. Even though I would, I prefer running these Python environments inside of Anaconda instead of Python virtual environments. All right, so this is a TensorFlow saved model. Now we're going to move into, and we're not going to open it. We don't really want to spend time doing that. All right, so we are done exporting there. We could export to ONNX, TensorFlow.js. Let's take a look at CoreML and also at TensorFlow Lite. Before we go and ONNX, let's take a look at everything, but then we'll go into TensorFlow.js. That is what we want to make use of today with TypeScript. And again, feel free to feel free to ask any questions on the chat or let me know if you have any doubts or comments. All right, so this is taking a bit. It seems, if we go to the topics, it seems like we're covering sort of TensorFlow.js. This is more Lobe instead of TensorFlow.js. I have to be honest. AI drawing, we're not gonna have time for this today, it seems. And Next.js. Maybe we can try to run our model inside of Next.js. That's something I would like to cover if we have time. And let's put this to the side. Right, CoreML model. Let's take a look at what core model is while this loads. All right, CoreML. Awesome. So integrate machine learning models into your app. Right, this is already exported. So this is our CoreML model. We have here an example which tells you this is the Swift code you have to run to be able to run your model inside of a Swift application. This is pretty cool, seems pretty straightforward, and this is something that I really want to take a look at. A model is a result of applying machine learning algorithm to a set of training data. While this is getting done, let's export as well to TensorFlow Lite so we don't have to wait. Export. And let's zoom in here a bit. All right, and if there are any newcomers, anyone that just connected, I will invite you to let us know who you are on the chat and maybe where you're connecting from and what you're looking for to learn from this live stream. All right, so let's close this a bit. So a model is a result of applying machine learning algorithm to a set of training data. This is kind of high level explanation. CoreML is the foundation for domain-specific frameworks and functionality. CoreML supports vision, natural language, speech, sound analysis, blah, 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 blah. And these are kind of topics that they cover and they probably let you train on device. But what we've done is create the model in TensorFlow with Lobe. and then export that to different formats. And one of those is CoreML that we saw. Another one is TF-Lite that we have here, similar files to before, label, signature, and then a TF-Lite single model that has everything. You can see 104 megabytes. And for the TensorFlow Core 1, we have 104 megabytes for the weights, but then the model definition is also 2 megabytes. TF-Lite is a bit lighter, but almost the same size. And also code here on how to run it using Python. This is good to deploy on the cloud and stuff because the TF-Lite runtime is a lot lighter, it's a lot smaller than the TensorFlow Core runtime. And lastly, we're gonna export to ONNX. Well, not lastly, but before we do the export to OJS. And I'm not sure how long it will take to optimize the model before we export to TensorFlow.js. All right, let's wait a bit. Yeah, and you know, if you're curious, I started a couple of weeks ago. We have to edit the videos as well, but I started sharing some of the workflows and tools that I do, and you know, this is pretty cool. This is the visual environment that I use. It's called Audio Hijack. This is the visual environment that I use to broadcast audio to you. So this captures my recorder, which has a USB interface from the microphone that I have here. And I have here the denoising filter. So if I remove that, you'll hear some background noise. Let's see. And now I can click. It learns, and hopefully you should hear less or none of that noise, right? So let's try it again. So we have this here. We have the denoise filter. Now we are going to activate the noise. You see that it's passing through here. Look at this line. So when I denoise or learn the noise print, that line will disappear. You see? So now only my voice is passing through, supposedly. Which is pretty cool. It's an awesome interface and really nice. There's a lot of stuff. I don't know if this is working. This adds some reverb. Hello. Hello. Hi. Hey, it's Nono here. And this is the Nono.MA live stream. Yeah, that might be a bit weird. I didn't really even hear it because I'm not hearing what comes out of this system, but yeah, you could capture audio from different applications and then loop them back with loopback to OBS. That is what's actually casting all the video to the video feed. And if you're interested in these things, let me know in the chat, let me know in the comments, on the Discord server, whatever, because I really like to share those how-to tricks and things of how I do things. All right, so somebody wrote on the chat. So it seems like Mossini. So Mossini just slid into the server. So I want to take this moment to say hello to you. Thanks for joining. I'm glad that you did. I'll invite you and Siboki that joined 2 days ago to introduce yourself on the introductions channel of the Discord server if you're comfortable with that, or even on the live stream, on the chat, or in the comments of the video. Yeah. Yeah, Sajay, I'm glad that you find that awesome. It's a really awesome tool I've known for a couple years now. It's made by these awesome people. So Rogue Amoeba, it's a company that does quality audio software for Mac OS, sadly not for Windows. But yeah, they have a pack that I bought that includes Loopback, Audio Hijack, Farrago, and Fission, and it's really nice. It's really nice. I don't think you have these other ones. I don't know what this one is. I don't know if this is new. Superior sound control for Mac. Yeah, maybe this is something that makes sense to get truly fast access to system devices. sound source, yeah, their UX design and how they do everything is awesome. So if you look at this is simply, it's really awesome. Let's see, I'm interested on learning more about these things, so let's take a quick look. Sound source in depth. So here, toolbar, ping the main window for floating access. System audio devices instantly adjust settings from the max output, input, and output. Sound effects. Per application, now every app has a volume slider, mute button, and much more. This is volume controls. Output selector, send app audio to distinct outputs, play music through your best speakers, and everything else to a secondary device. That is pretty awesome. So you can put your audio from the system or something into your AirPods, like output and stuff, and then sound effects into the speakers. Enhance the quality of audio heard from any app or system-wide device. To only one device. That's pretty cool. Yeah, so all right, so let's I like to deviate a lot from the main topics, so let's get back at where we were. All right, so we have exported, and we're gonna export the last one, so TensorFlow.js. So we have all of them here. And for this one, well, let's export without optimizing right now. We're not gonna use this in production. But we have here the TensorFlow.js model. No, the TensorFlow, the ONNX is the one we looked at. Looks really similar, right? And we have a Python example on how to run this example with Python, skeleton code, blah, blah, blah. And it's really similar. So how to load, predict, and pre-process an image, right? The thing with this is ONNX is not only for Python. So if we take a look at this, so ONNX, let's see here what ONNX is, what Core ML is, briefly. Quick preview of my audio hijack workflow and overview on sound source from Rogue Amoeba. And I do like to take detailed notes of everything because these will save me a lot of time later, and that is really, really important. Okay, Open Neural Network Exchange. All right, so let's actually make a quick video on this because we can maybe release this later. Hi everyone, it's Nono here, and I'm just gonna show you a really quick overview on ONNX. If you've heard of this is a framework that stands for ONNX stands for Open Neural Network Exchange, the open standard for machine learning interoperability. You might have heard of formats like TensorFlow Core, TensorFlow Lite, TensorFlow.js, Core ML, Android Studio, many different formats that you can, even PyTorch, that you can export to from different platforms, different frameworks, and different tools. ONNX tries to define a common set of operators that work cross-platform and that you can deploy to any device, and it's in pro of interoperability. I said any device, I don't really know. It seems like it's for many different devices and environments. I know that you can run it in C#, you can run it in Python and Pro, you can run it in many different programming languages. A lot of people that use it here, and a lot of community, a lot of things. Let's see what this supports. Machine learning framework, cloud services, and pre-trained models. So you can build your model, export to the ONNX format, and then use ONNX for inferencing. Accelerated inferencing uses supported runtime, export to another framework. Let's take a look at the supported tools. So this is a quick list of what's supported here, which I think it's a bit crazy to me. I'll move a bit to the side in case I'm covering that. So you have Caffe2, Keras, PyTorch, TensorFlow, XGBoost, is Chainer here. All of these ones, scikit-learn, I'm just kind of the cognitive toolkit, core ML, so many different frameworks, right? Cloud devices, Microsoft, Azure, and Azure Cognitive Service, Custom Vision Service, and something else, pre-trained models, vision and language. Get started quickly with pre-trained models. Inference, deploy, and is AWS here? Runtime, using runtime design to accelerate. Okay, so this is runtime, so you can run on Windows, Intel AI, NVIDIA graphic cards. We don't see Mac here or iOS, but that's okay. I guess like you can also convert models, and you have Core ML for that. You can visualize in Netron, Visual DL, and Zetan, optimize ONNX. To fine tune, okay, you cannot see this, but I'm gonna put it here. So if we optimize, this will fine tune your model for size, accuracy, resource utilization, and performance. And one thing that is more like a practical use case, you can train a model, so a machine learning model. You could train it in Nono.AI. So for example, here I have a classifier that classifies sketches, so hand drawings, into the ones that have color and the ones that don't. And later we can, after we train, we can export, right? So we can test our model, we can export. And look at here, one of the options that we can that we have to export is ONNX, and we can use your models in universal apps, right? So we will click here, and then we can choose where to export to. So let's say that we'll export it here, and then we can choose to optimize before exporting or to simply export. If we click on export, what we'll get is a folder like this one, in which you have not only the model, but an example on Python code on how to run this model in Python, how to process the image as an input, predict, and also load the model, or create an inference session. You have your labels, you have your ONNX model, you have the signature that defines properties of the model, like the name, the label names, and some of the types of those labels that you're getting, the outputs. And with Netron, for instance, you could preview this model, right? So we can preview the architecture of a model that we've trained or we've exported to the ONNX format. You can see here, this is looks like MobileNet or ResNet, I think. And at the end of the day, we have the output. You can see here the format ONNX before, and it was produced with TensorFlow to ONNX 1.6.3. And if we look at the input, so this network gets, let me see if I can click on this operation. Yeah, so this gets a 224 by 224 RGB image as an input, right? All right, so that was a quick overview on ONNX. We haven't really seen anything on how to use it, but hopefully that gave you some hints on what it is. Thanks so much for watching, and I'll see you next time. All right, so we have here our TensorFlow.js model. It's getting late, and we don't have it yet. I don't know why, but I don't know what happened, but that's not there, and we wanted to export. So we're gonna export, we're gonna click on export, and that should show up here. What's going on? All right, what can we do now? Let's close that, and look. All right, while this is exporting, this is not gonna take a lot, but I'm gonna take a really quick break, and we'll be back. Leave any comments on the chat of what you wanna see, if you have any questions, or if this is going okay. If you're online right now, let me know. What do you think today's live stream is looking like? Do you think this is being helpful? It's boring? Just let me know. I'll be back in a few minutes or a quick second. Bye. Okay. All right, I'm back here. We're gonna make one last push. Couldn't export. It was a problem exporting your model. Please report this issue to help the team find a solution to it. Shared logs. All right. It seems like we have to share here. All right, so let me just take a quick look here. Right. Load couldn't export to TensorFlow.js. Well, I'll just send this. I don't really know what's going on, but this is a blocker because this is the main thing that we wanted to try today in this block, and we can't. So that's a pity. I know that we might have done that before, so we might have this on another of the live videos. So maybe not here. Maybe to all right. We exported to TensorFlow Lite, not to TensorFlow.js. That is really weird. I don't know what's going on. All right, let's close this then. Okay, so I have that. I'm going to archive the folder for today's live stream. I'll keep it here, so that's not something I'm committing to the web yet, but let's see if there's something that we could. Maybe the download sketches and this XML, so we're gonna put that into our folder. So I'm gonna put it into folder, make a folder for 28, CD28, and we'll open that and move that there. All right, so we're going to git status, git add status. So I'm committing those files, and I'm gonna put here add bash scripts to download Nono sketches. Right, we push that, and that should be online at GitHub Live. Cool, awesome. So that should be here. You can access it. So that's a silly script, but in case you want to use it for something, so we'll put it here. Bash script to download images. Cool. All right. Let's take a look then at some examples of ML5.js and TensorFlow.js as a last moment. Okay, so we have previous videos on TensorFlow.js and ML5. I did actually ML5.js Nono ML5.js glitch. So yeah, I showed this last week and we did it 2 weeks ago. So this is an example that classifies the picture that you input to it, and in this case we're classifying this tiger, right? Tiger, Panthera, Tigris, and it seems like it works pretty well. This is JavaScript, so this is not TypeScript, but let's take a look. TensorFlow.js, let's take a look. Some of the things that we want to do here, right, to set some process is that we want to train. So we have some links here from past experiment, right, where we train pigs to pigs. So let's make this a bit bigger. And YOLO v5. Yeah, we kind of stopped the experiment of YOLO v5, and this channel is a bit older, so newer. Nono.MA playlist life, I think that should be it. Yeah. So these here, now we don't. Oh, we have it on the covers. Train. Where do we have pigs to pigs? So we have pigs to pigs here. 17. Where do we have this? Maybe in videos. All right, yeah. So I can just go to colab.research.google.com and I can find that notebook that is called something pigs to pigs. Pigs to pigs. Search. Condensed. All right. Yeah. So this is. I'm just trying to do this because if we don't make sure, if we don't know what version we are training our model with, it's really hard to convert it. Like it wouldn't work necessarily. Okay. So mount content drive, trying to do forcibly, blah blah blah. Edges to tulips. All right. So let me see if this actually works. So let me see if I can authorize. So we're gonna put. I don't have Colab Pro right now, but we can still use GPUs. So I'm gonna connect to a runtime. And what we want to do, this is an experiment for that TensorFlow.js section that I said we wanted to do today, in which we're going to try to train a TensorFlow model with pigs to pigs. It's not going to work great because we're not going to train for a long time. I don't know how long it takes to train in full, but we'll have a checkpoint, and that checkpoint we want to see if we can directly convert with TensorFlow.js. I'm suspecting that we're going to have problems because it's not going to work perfectly, and we'll have to do a workaround and take a look offline and try to do it in the future. But yeah, TensorFlow.js, we also have videos. I need to clarify a bit where all this live stream is going and some experiments that we can do more thoroughly, and maybe do some parts offline, maybe do some parts in which we collaborate on the Discord server. And another idea is that maybe I have to do some extra live streams on the weekends or something, because the time that I'm having here in these 2 hours or 3 hours every week, it's not enough to do in-depth problems, or at least I would need to have a really clear follow-up where I continue exactly on what we were doing last week. All right, so we have TensorFlow 2.4 here, or well, that's what we had. Let's see what we have now, probably 0.1. Okay, we're gonna close these things, and I'm gonna zoom in so you can read, and I'm gonna authorize my Drive account here. Right. Load. Wait, okay, so this is above here. Okay. All right. So we have it mounted here, and let's put this like this. Thinking if I always do this, maybe this should be here at the top. That would be a good addition to the background, right? Like I always put the screen around here so it doesn't conflict with, I don't cover anything on the screen. So maybe the logo could be here. All right, so let's load this again. So TensorFlow for buffer size, but blah, blah, blah. edges to tulips. That's the data set that we're using, and that's on my drive. So if I go to drive.google.com, we might be able to see that. Let's search here, edges to tulips. Right, so this is right here, and we have two parts of this data set. So we have training, which are pairs of edges to actual images, and we have validation, which is the same, but just like a percentage of the data set split there. All right, so let's go back here, hit the features, testing pix train models, and we do have models here, but trained with probably with an older version, 2.3 or 2.2 or something. Maybe, yeah, I think so. Because if we look at GitHub, the TensorFlow releases, 2.5 is coming. So when is 2.4.1 released? January 1st, and our notebook is from so TensorFlow 2.4.0 was released one day after the notebook that I created, but it said 2.4.0. yeah, okay, so we actually don't have the latest. It might be compatible, but it's worth just training to try it. Okay, so we put this, we train that there. So this should load a sample image from the dataset right now. Okay, yeah, so that seems to be working. That's a weird flower. That's not a real flower. All right, with some helper methods. This is what we loaded last time. So we're gonna print that example. Load train image. Nono is hiding his Drive account for not being hacked. Lol. Yeah, I mean, I guess so, right? I don't really know if you can get my token. I don't know if you can get my token and access, but I'm trying to do some separation also between the accounts. Probably have to create an account specific to the live stream or something. But yeah, that tells me that you guys are paying attention. I'm thinking, sometimes I think, oh, there might be no one online or something, and yeah, this stays live all the time, and it's sometimes there is actually this feature in OBS that I haven't tried, that you can delay a bit the video. So the video that I'm streaming is a bit delayed, and you can if you see that there's some sensitive data on screen, you have like a few seconds to get to OBS and then click on maybe deactivate, and you will be deactivating things that happened on the past. But yeah, I don't know if that's making a lot of sense right now. All right, so yeah, and I have like a bunch of I have a bunch of these things. You can change a lot of these things as well. All right, so let's keep going. For example, input. All right, output channels 3. Important thing, we're just gonna train for one epoch first and see what happens. All right, so the model shouldn't be able to generate anything that makes sense yet. And I was a trick there with OBS is to disable the preview, because that actually consumes a lot as well. When you're previewing the image that you're feeding, it's I think it does consume a lot of resources. All right, so what are we doing here? So down, model, expand this. All right, so that's done. Done. All right, so this is an input. Lambda training procedure is shown below. Discriminator, I'm not going to go through any of this right now. We're just trying to get a trained model. And we have a live stream. We have a few live streams that cover this, I think. It's like 15, 16, 17. Those are the live streams there. Generate images. All right, so now when we get to training, let's make sure here we're just going to put 2 epochs for now. Well, let's put 5 epochs. I mean, we can wait a bit. Here, there, H9 fit. And now we run the training. All right, so we're training now, and this is probably going to be fast, right? I'm not using any of the super high-end GPUs, but with any type of NVIDIA GPU or GPU that is running here, we should be good to go. Maybe. Not sure. Is this running on GPU? Yeah. We just don't know which one we have. All right, so we have some stuff executing 31. All right, we have some information below here. Mirror cell in tab. Open editor settings. Cancel. So I remember there was something here. Command palette. No. View. Not sure is in here or not. Okay, epoch 0. It might take some time. Is it taking some time for some weird reason, or because I don't remember this taking so long? Okay. Tools. Settings, diff notebooks. Runtime. All right, now it's training. Okay, and it's training pretty fast. Cool, awesome. So let's see. Also, if anyone's watching online, if you're watching offline or whatever, I'm looking for people to collaborate with the project, maybe generating content or like editing some of the contents that I'm producing here. I'm recording. I plan on record a lot more of tutorials live and offline. And one thing, maybe if you wanna do that, I might record tutorials offline, right? Which means I'm not gonna be doing this live stream while recording them, or maybe for things that have more sensitive data or things that I have to post process and edit afterwards. If you're interested on being on those, let me know on Discord or on the chat, and I'll add you to a list or a channel on Discord, like a private channel. And if I do any of those live stream sessions that are private live stream tutorial recording sessions, I'll add you there. That's something that, if the thing grows, that will be like a thing. But yeah, it's just recording tutorials, and I think it changes a lot if I do that offline, but I still do it live, because the way that you deliver content, I think when there's people behind the camera, is a lot different. All right, so we're generating something there. And one thing I haven't looked at is how many epochs. Okay, we're saving a checkpoint every 20 epochs. So we're not going to save any checkpoints with this test, which really sucks. Edges to where do we have this here? All right, so the train models, where are we saving this to? That's the question. One epoch. Generator save, H5 name, where is that? H5 name, suffix. All right, so Pix2Pix train models, Nono. I don't even know if that exists anymore. Oh yeah, here. Awesome. So these are old. So we're gonna make this list. January 21st. Yeah, one thing we can do. This is the last model that was saved, so we can download this one. Yeah, let's try that. That's pretty fast. All right. Cool. So we're training here, and I don't think this is gonna train anything, right? Oh well, okay, yeah, we'll save the last one. So we'll save epoch 5, and I'm going to leave this here. Feel free to put any comments or any questions on the chat that you might have. This is gonna take a bit while that's getting done. we could just make a test and try to re-export this. Yeah, I just don't know why this wasn't working. Well, maybe let's try that option to optimize and export. Just remember, it has been optimizing for X seconds. All right, yeah, and we're training on the cloud, so this will not interfere. And I'll be back in a second. All right, so that sound means that the model was optimized, but it's not being exported yet. So we don't know if this is gonna fail again or what's gonna happen. Okay, so I'm back, and so one thing I wanted to do, so if we open this with Netron, this is a big model, but I think it can be loaded. Okay, that was pretty fast. So if we click here, there is 2.4.0. This means that we trained this model with TensorFlow 2.4.0, as easy as just getting the converter for that version, I guess, if we can. So TensorFlow converter, and maybe we can choose a model. TensorFlow comes with a variety of pre-trained models that are ready to use in the browser. Alright, so if we're gonna do this, we might as well do it properly. So let's make a title slide. Right, so change master blank, and maybe, yeah, I don't know. TensorFlow converter. This color might be a bit aggressive. Right. Hi everyone, it's Nono here, and this is an overview on how you can use the TensorFlow converter to convert models from one format to another. In this case, we want to try to convert TensorFlow Core or TensorFlow Lite models into TensorFlow JS models that you can use to deploy web applications. Let's take a look at it. All right, let's get out of this. Yeah, and right, quick question here by one of our participants today. Right, let's make another video here. Right. Well, thanks for the question, Ricardo. Hi everyone, it's Nono here, and we're gonna reply to another question from our attendees to the live stream on Thursday afternoons here in Spain, or midday 1 EST in the Americas and US. The question says, Nono, have you tried the PyTorch implementation of Pix2Pix on Colab? I've trained a few models to draw floor plans, but the predictions made on Colab of my trained models are totally wrong. Well, first of all, thanks for the question, Ricardo. I have to say I haven't, right? This is, I think you're referring to the original implementation done by Philip Isola and stuff, so on his team. I used the port that was done by Christopher Hesse to TensorFlow, and later I'm using the TensorFlow implementation. I would love to hear from you as well. Why are you interested in using the PyTorch version? Is there anything different to the code? Is there anything different that you're expecting? If you point us to where you trained this from or something, maybe that's something that we can take a look at. But yeah, I don't have a lot more to say to this question. Yeah, we can maybe have that discussion of talking why talking why you want to train that one. So PyTorch, Pix2Pix, I guess that's the original, right? Pix2Pix, PyTorch, GitHub. That might be the original repo. Well, not this one. This one. Yeah, we're gonna close low because it doesn't really do anything there, right? All right. Model conversion. TF.js converter. Can we install a specific version of this? So that's kind of pip install. So TensorFlow.js wizard. All right. So for this, let's try just to create a Python, a Conda environment. So we're gonna do here Conda create let's see first which ones we have. So we're gonna list the environments here. TensorFlow, yes. What is in there? TensorFlow.js, TensorFlow.js, Conda list, TensorFlow.js. Right, it seems like we have it here. I don't know what version. Let's see. 2.7.0 dependency versions, Keras 2.4, TensorFlow 2.3, so pip TensorFlow 2.4.0. Let's try to do that. TensorFlow JS 2.7. Right, so we're downloading TensorFlow 2.4.0 because the model that I have downloaded here has actually been trained with TensorFlow 2.4.0, and it says it here, which is important because that might lead us to huge problems if we don't do that. And I'm not sure if the converter works with any version that you want to train with, but just for to stay out of the possibility that this is going to be the error, we've wasted many hours before with this. I'm just going to use TEMS 2.4.0 for everything and try to make that work. All right, so we'll create the 24. Well, let's go to the actual. I'm not sure how big are those. I'm hesitant. We can export these ones anytime if we need them, but we can maybe keep the two TensorFlow ones that we have here. We're going to try to export them to TensorFlow JS. And also the other model. All right, and we have this model here. The model on local machine works perfectly, but when I upload it to Colab, it doesn't work properly. But doesn't it work properly when you train, or you already train it and try to use it on Colab? All right, converter. Right, let's take a look here. TensorFlow JS converter, and I'm gonna go and activate this and make sure that we have the right versions now. Value missing input path. Wizard. All right, so let's try to build a command here. So please install PyInquirer using the following. Right, we need to install one more dependency. So it seems like TensorFlow JS Wizard is a tool that helps us. Right, I don't know what that is, but we're just gonna try to use the wizard, which is a tool that helps us not have to build a command manually. So welcome to TensorFlow JS Converter. Please provide the path of model. So let's actually put this. No, let's make the system dark so we continue with the dark interface, right? Right, great. Hello Lourdes, nice to see you around as well. All right, please provide the path of the model file directory that contains model files. If you're converting TF model, please provide the URL. All right, so we provide something weird happened. I don't know where our TensorFlow model went to the other desktop. Okay, so we put it here. All right, that's it. What is your input model format? So we can now cherry pick here, so we can zoom in a bit. So we're gonna choose from these options. So it would be, all right, bad. Okay, we start over. So TensorFlow _ wizard, TensorFlow JS _ wizard. The path, we provide this one. Now our format right now, I think, is Keras save model, I believe. Let's try that. No compression. Do you want to compress the model? This will decrease the model precision. Use arrow keys. Okay, so where are we? Well, which direction you want to go? Okay, let's go to desktop. The output already directory exists. Do you want to write it? No. Output or converted. All right, so now here we have a model converted to TensorFlow.js, which is impressive because I hadn't been able to do this before. And this is cool. So we have the model in TensorFlow.js. And so load model TensorFlow.js. Save and load models. And weight model, local storage, my model 1. What do we have to do here? So let's try to quickly do a so we're gonna make an index file where we will load converter. Okay, so import. So import everything as TF from TensorFlow, TensorFlow.js. Okay, now a constant model, await TF, load layers model, and then I'm not sure how to load it locally, but let me see. Can we load it with local storage? Model.json or model, right? And we'll just save this. So we have to npm init, yes. So I'm creating a new node project and I'm gonna do npm install TensorFlow.js. So we install TensorFlow.js there. Local storage browser only. Native file system, Node.js only. All right, so we actually have to do this with file. So file, model, all right. When running on Node.js, we also have, Node.js. So this is how to, so here's how to load from a model from your native file system using Node.js. So this is loading a local file. The schema is file, so we can use this code. And this is what it says here. When running on Node.js, we also have direct access to the file system and can save models there. The command above will save 2 files to the path specified in the scheme. A text.json file named model.json, which carries the topology, blah, blah, blah. Loading a TF model. Right, loading a TF model. Hopefully we can also load it from there. Okay, whatever, let's see. So let's see if this works or not. TS node index.ts. We might get an error. All right, await, allow model, await, TF load. We do have an example on the live stream files. Not that one. Not 22. Not 21. Not that one. Okay, this one probably. Where we have to put this async block. Okay. All right. So what I'm trying to do is just to see if we can execute this code and load the model. and I can try to do that from here. So I can try to do it from here, where I'll do ts node index.ts, and we'll probably see the same error, but hopefully not. All right, well, it seems like the model might be working there, and let's see. All right, maybe we need to all right, so throw new type error. Only HTTPS protocols are supported. Only HTTP blah 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 blah. Okay, so for this I'm going to use HTTP server here, HTTP serve npm install global HTTP server. Right, so we're gonna have to serve our assets in an HTTP server for Node.js to be able to load it. So we'll do an HTTP server of our local folder at 8080. So we have that here, and we'll see this file here. All right, so I can see a message. All right. Awesome. Okay, so cool. Okay, so yeah, I see the message that you sent me, Ricardo. Okay, so here we have a server, right? So we can say that we can load the model from here, and what we can do is we can make it there. So for example, we'll put our model here, and now we have that directory that's going to show up. Right now it's empty, but we can put anything we want there, and we're going to put our model. So we'll put all the files of the converted model there, and all we'll do is now we can use that syntax that we saw to load the model from an HTTP server, right? So blah 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 blah. All right, so we now have this. We have model, and doesn't have anything. Now it does. Now it has this JSON. So now we're going to put our model URL here, right? So you can see it. I'm gonna put it like this, or maybe let's just put this. Well, it's okay. We'll just leave it like that. And hopefully now this works. So go clear here. Might work. Hi there. Looks like you're running TensorFlow.js in Node to speed things up dramatically. All right. So this is the model. So it seems that we've loaded it, which is pretty cool. And let's read that message again. So if we were to execute this. And stop it. This is that we need to install the core part of TensorFlow. Node GPU if you have CUDA, TensorFlow.js Node. So we can just run this to install TensorFlow.js Node, and I guess we have to load it. TensorFlow.js Node. Yeah, maybe the only thing we need to do, I think, is this, and we'll just do this. Not that one. So clear and ts node index.ts. And note that right now I'm using ts node because I'm writing TypeScript, but this is something that will run in JavaScript as well. Right, so this is okay, is training false. Nodes by depth. Right. Okay, so what can we see here? We can see all the layers. So this is a sequential model. And yeah, I guess we just need to predict. So I'll add these resources to the links. So all right, and TensorFlow.js predict. All right, let's see an example. Predict, right? Predict. So TF tensor, and we need to format our data as a tensor. The easiest thing here is that we need to do model.predict and then put here like an input tensor, right? What is going to be our input tensor? I think we could do something like tf random random uniform. Yeah, random uniform. All right. Print. And here we do I think the model signature should be 112, no, 256 by 256, I think, and 3 channels. We can see more information about the model in the model.json file. So we make this a bit bigger. So we have the model config. So let's try to weights manifest. So we have the config. So you have the layers, the input layers, the output layers. Yeah, so we have the batch input shape is what we created. So 256 by 256 by 3 RGB channels. And that should work. I mean, in my mind, I think that should work if we do this operation here. So let's say wait console log. So now we do input tensor print. I'm not sure if we need to do a wait there, but let's just try to do this. Let's run that and see if we can create a uniform tensor. Well, I'm loading the model before, so we should probably, just to test this thing, we shouldn't need to. All right, so that's working. And to see what we're doing right now, I'm gonna stop loading the model and I'm gonna make this input tensor just 2 by 2 by 3, right? So we do that, we execute this in TensorFlow.js code, and that's gonna load TensorFlow.js. And now we have here, this is a 2 by 2 matrix with RGB values. So this is first RGB, second RGB, and then the second column, first value, second value, right? So we're creating a matrix that is has this dimension or this shape, and that's like a pix-to-pix input image, and that's what we're creating with our algorithm, right? When we run this code. So ideally, we would be able to pass that input tensor through here, right? So we'll do something like this and prediction, and now we can do prediction print, I think, and that should work. Print doesn't exceed tensor rank, tensor rank, blah blah blah. All right, let's just then try this only. Okay, what is going on here? To enable them in operations, blah blah blah. CPU feature word, right? So expected input 2 to have 4 dimensions, but just got shaped that. All right, so we need to have, actually, I mean, here is pretty easy. We can just make it a batch, but when we have images that are, just one image like this, we actually need a batch. So this is telling us that we can send a batch. We can send 5 images, 1 image, or whatever, and we actually need to batch our input images. And we're getting this, so we're getting like a tensor, and the shape of the tensor is the same batch, so it's just one image of that, and we're getting to enable them in order operations. But okay, so we're actually getting this model to work, and I'm pretty excited because this is the first time that I can just so smoothly convert a pix-to-pix model into TensorFlow.js, which is pretty cool. I mean, at least I think it is. And we have the server here serving the model, and these files here, and prediction 0. Can I do that? Yeah, I'm not sure how to access the predictions, and maybe, just maybe, a good way in which we could do that is to make a TS node session. All right, so let's try to do that. So we're gonna make a session here, and we're gonna try to load the code that we have above line by line. So we're gonna import this here. This is exciting. I hadn't thought of doing it this way. So now we can print TensorFlow, right? Yeah, we have it there. And we're going, so this is a REPL, and now we're going to define so we're gonna let so our model is gonna be, it's gonna stay here, right? Model presenting type. So what type? TF layers model. This is gonna be a TF layers model object, and we're gonna define our model with this when we load it, and we'll do this later. So we're going to run this here, and well, we don't really need to move this out right now, but well, let's actually do this. All right, so let's move this here. All right, so what we're gonna do right now is we're gonna execute this. So right now, if we type model, this doesn't exist, right? But we can define the variable, and then we have it that is undefined. Now we're going to put this async block here and execute it. So we have a promise that is pending, and now we should, well, I mean, this is loading the model actually, and now we can see that our model is here, right? It exists as a variable. So now I'm going to, so I can execute this code now without having to reload the model all the time. So I can go here, execute it, and that's actually processing. So it's actually requesting a prediction, and I'm not sure why this is not returning. Oh, undefined. All right, but if we were to do this, right, if we actually now execute another prediction, that's pretty fast. I mean, you can see yeah, you can see that this is pretty fast, right? It's almost instant. So now if we take a look at that prediction, right, we have the shape, the tensor, the data ID, and we need to look at how to get that data. Again, we can go to that example that I had here with ResNet. We were predicting the zeros, and then from that output, we're getting the data as an array. Let's see if we can do that. Is that an await operation? So we get the output, and then we actually have to do an await here. Property array that's not in tensor rank. TF rank. Output predict. So predict, await, output, output print, output. This is the same. Yeah, and nice to see you around, Marcos Milnitz. Glad to see that you connected online. And thanks for letting us know that you're online. Where are you connecting from? All right, so let's see how to do this. So this is a TensorFlow TF rank. TensorFlow TF rank get prediction. All right. TensorFlow.js predict result. Result, argmax data sync. It has confidence in the prediction. All right, so this, it doesn't really matter. We disconnected from here, but I think we do have the model, right? So we have the model after 5 epochs, which, it's probably shit, but it's there. I'm gonna delete it because we cannot do anything with it. Okay. So model predict. Okay. So we have TensorFlow.js sample predict. Make predictions. All right, so we go to the predict method dot predict. So we end up here. We have the predictions multiply label data sync. All right, that might be a new method that I haven't seen, but whatever. Let's just try there. Data sync tensor rank tensor. Predictions, model predict, blah blah blah, data sync, TensorFlow.js, data sync. Yeah, is anyone familiar with this data sync syntax? I haven't really seen it, so I don't know if we have a race sync. Well, let's see, we have autocomplete, right? Prediction, TF tensor rank, maybe 0 dot. Dot predict. Data sync, model input 0. All right, let's try to just run it and see if it works. Data sync, even if it doesn't like it. So we can copy this here and put it. Oh. Data sync. Data sync. Data sync doesn't exist. Maybe that. Maybe. Right, let's see. All right, cannot read property data sync of undefined. Array sync. Yeah, this is probably gonna throw the same. Okay, so how can we get to know what this prediction wants us to do? Async. All right, we have here this, so it's a float 32. We have the shape, strides, yeah, so we have all those pixels. So this number here corresponds to this number. And ID rank type, get array from tf rank TensorFlow.js. And this is probably can we do print? No. So what is this? Tensor. TF tensor, TF rank. TF tensor, tf rank, tf tensor, tf rank, tf the rank, tf the rank. Where is that rank? tf tensor 4D, tf tensor array sync, data sync, print, clone. Okay, let's try data. Array to string, print. Maybe wait. Shape. Yeah, this is a blocker for me. I never know how to deal with these things. Span dims, mirror path, set, get, buffer. Wait, model predict. Right, it's coming to an end. Can't find a solution. So this is batch input shape, inbound output. Let's look for output. Oh, output shape, output layers, convolution transpose, input to. I don't know, man. I don't know what's going on. Right, let's put the error. Let's put the error there. So prediction, and we want to get the array sync, for instance, right? So we search for that. All right. Property print doesn't exist on blah blah blah. TensorFlow.js, blah blah blah. Who wrote that example for ES6 for TypeScript? Since predict can return either a tensor or tensor, depending on how many input your model you have to modify the compiler which one it is. Model predict as tf tensor. All right, I don't know what's going on there, but that worked. So the compiler doesn't complain now. So we have a tf tensor. We just needed to put tf tensor there, and after we do that, we get autocomplete, which is awesome. All right, great. And we can even do print, right? So we can even do print, hopefully. All right, not a number because I'm not sure why. Pending, it's pending. Array sync, and we log it. Okay, so what we can do as well, well, let's just run it and see that it works. So we run this thing and this is working. So we have a bunch of numbers there and this is 256. We close this once again And now, supposedly, we can run our entire example, ts node index.ts. Boom. Oh, what's happening? Oh, okay, I'm inside of the repo, so exit. All right, so now clear an index.ts with ts node. So now we're gonna load TensorFlow. Boom. Can read predict of undefined. All right, great. So predict. We're waiting, so we're asynchronously doing two different things. So we gotta wait here, and let's try once more. So we're loading TensorFlow.js core. We're now loading. Oh, let's actually do one thing. So let's actually log things here. So maybe loaded TensorFlow.js Node.js. Now here we can say loading TensorFlow.js model. Boop, boop, boop. And now log predicting. All right, so now we execute and say loading TensorFlow.js model, right? Now that's loaded, and we're loading the TensorFlow.js model, and now we're predicting, and then we have that prediction. All right, so if we want to see how fast it is in predicting, we don't really need to log these things, I guess. We can make many of these predictions on the fly, even with the same data. So we could do this and maybe log here. So maybe put this thing here, predicting, and now we copy. So now we run this thing again. So we load TensorFlow.js for Node.js. We're now loading the model. And once the model is loaded, we're predicting pretty fast. And that's pretty cool because it means that, you know, the predictions are super fast. And just once more, do you guys have any questions? I'm glad that this worked out, and we're gonna be able to check off that TensorFlow.js section from this video. Is the only thing we've been able to do. We didn't get to do the other two, but it's okay. We've looked at Nono.AI and other things as well. And we've converted a pix-to-pix model from TensorFlow core Keras, right? So convert a pix-to-pix TensorFlow core Keras model to TensorFlow.js and make pix-to-pix predictions with TensorFlow.js. So we've done those, and once more we missed it. So how fast is pix-to-pix in making predictions on a computer while we're live streaming in TensorFlow.js? So when the model is loaded, boop, 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 boop. All right, so we made, you know, more than 1 per second, that's for sure. All right, so this is great. This example we can upload to the cloud, and you know, we could so we can say, all right, we could put this here. Right, so we can remove this code here. And we have this example, which I'm going to copy into the repo, and I'm going to delete this one. Create a lot of stuff there. right? So this would be a node git ignore. And we're just gonna copy this. All right, so we're done for today, I think, almost. So we are going to remove those nodes models. So we're gonna go to desktop, TensorFlow JS sample. Look at this. We remove the node models because we don't really need them for the repo. And then we move our model to desktop, pix2pix model TensorFlow.js. Remove that. We have these files, and now move TensorFlow.js to TensorFlow.js pix2pix predict. That we have that, and now we move that one that's more to live 28. Sorry, I'm in the middle. Live 28. We go to live 28 and but that's not where I want to put it, right? So we want to put it on what? Okay. Wait. All right, so we're gonna delete that. Okay, let's see. Less. Right, so we'll remove the store, but we're actually going to move everything. So list everything here. Okay, move everything here into live 28. Open live 28. Why not? All right, git status. Okay, yeah, we're in the right place. I just need to open and rename this. Oh, okay, yeah. So pix2pix predict TensorFlow.js predict pix2pix. That's good. From more generic to more specific. We put it here. Bash download images. All right, so now we go back. So we go back again. We have these folders. We add these things. We commit for 28. We add TensorFlow.js pix2pix predict model sample. Great, and we commit, and then we open github.com live. Awesome, and we have that here. So we now have this example also on the cloud, so you can run it on your machine. You will have to serve the model, so maybe it's good if we document this here so people are not confused. You actually need to so put it here. You need to load the model from an HTTP or HTTPS server. If your model is local, you could serve its directory using npm's the HTTP server npm package with npm install npm i HTTP server and HTTP server path to model. All right, so let's add that as something that we've done. Git add. Right, and we comment, and then we push. We get that comment here. All right, so with this comment, I think that's okay. We just now need to do some house cleaning. So pix to pix model from core to TFJS. We add live for 28. We're gonna put that here. We delete these two. We delete these two. The sketches model actually. We could have done something like this, so we could have also done conda activate TensorFlow.js, and we could have done TensorFlow.js wizard and selected this model. I think I'm not sure if the PV or the folder. So we put this one. So the format is TensorFlow Keras. I'm not sure. Save model, I think. Yeah, so we put the directory. No. Which directory you want to say? Okay. All right, so we go up, put the directory instead. Okay, once more. I don't know, it might be that this is actually Keras. Keras save model. Okay, let's read it. Welcome to Tensor. Please provide the path of model file or the directory that contains the model. The model file. Right, so yeah, this is the path. What is your input format? Model format cannot be detected. Use arrows. Keras? Right, yeah, I don't know. This doesn't work, but we should be able to convert it this way as well. But we're gonna delete this for now. This is an empty directory, so that's also going away. I'm gonna do what I said before I forget, otherwise that's gonna happen. Maybe we could have this this background, like copy of it. We open this. So when I open a terminal, for instance, right, I put this thing more or less in here, right? So we want to take this into Photoshop. So we just bring this into Photoshop. We put this here. And what we want to do is just get this little character and maybe just put this here, paste it, and bring this thing here. All right, well, let's try that and see how that plays out. Yeah, okay. Good. So that seems to be what I wanted to do. All right, so we have this this week's live stream thumbnail, which, it's in here. And we haven't covered all the topics. Sad face. But it's okay. I mean, I think we saw... Wait, what? Why? Not done. Check. All right, there you go. So done. AI drawing, not done. Next.js, not done. Should we maybe put this like this? Seems to be extra work. Maybe, I don't know. I'll try it this time. So I like to try many different things, and then I end up always doing things differently. All right, so done. That's good. Put this here, and we're going to update the live streams image. So I'm just gonna put this here quickly and change that thumbnail. Right, that should be good. And now, what else can we do? So we have the slides for today. So next week, we're not gonna have a live stream next week. We can't. I have some other event, and let me see here. Right. So that would be Thursday, 6th of May. Right. So that's gonna be May 6th. Supposedly it's gonna be live 29, and we don't know anything about the color yet. We'll hide these things. We'll load this week's thumbnail. All right, and that should be it, except for the color, right? What color are we gonna use? I haven't settled on any colors yet, so I have to be changing. And probably, I mean, the only thing with the color is this break sign, which animates, which I think I should change in some way to not have to rely on a GIF to do that. But I can also probably just have only this slide on a specific color and forget about that. All right, in red maybe makes sense. Okay, we're gonna download this. Oh wow, so I've been working with Dropbox on all the time. That might have slowed down the live stream a bit, but I don't know. If you haven't noticed, I haven't really noticed anything, so it's not a big deal then, at least for today. All right, so this one we're gonna put, and we're gonna put here. Maybe we need to put a less aggressive color for the breaks, but anything that's changed is this. All right, and we'll hide this one. And one trick that I have is that I do put this block here in the background, and then you can choose any color. So I could choose a new, like a completely brand new color here. Let's say we pick some green or something. I imagine I just pick this color, right? I click on done, and then the entire set of slides gets into a new color coding. This is all having opacity, right? And it's all in Keynote. All right, so we have the slides ready for this live stream. I don't know if it'll be this color, but we do have them there. And these are the slides for today. So reminders, we check the thumbnail, we schedule the next live. Maybe to be sure that we do that. Let's do that now. Schedule stream, we'll just use the same settings as last time. Remove the chapters. $29. So that's here. It will be 7 p.m. for me. This is going to be private until I release it. And create. All right, so that's scheduled. That's what we had to do. Okay. And that's it. All right, so as always, not here. Well, as always, okay, I'm really tired now. Well, before we go, I'll remind you that it really helps if you like the video. It helps support the channel and other people find the videos. And I'll remind you to subscribe if you want to get notified when I go live next or when I upload new videos. You can join the Discord community at Nono.MA/Discord. A lot of people already there and more joining. Creative people and people interested in coding, design, machine intelligence, and many other things. So I'll invite you. You can go to that QR code or just to Nono.MA/Discord. That's an invite for you. And yeah, without further ado, thanks so much for listening or for watching, and I'll see you next time. I don't really know what I'm saying anymore, so I guess I'll just I'll just take this out. I'll take the background out. I'll leave, so I'm not here anymore. I'm here still, and I'll see you probably. So I'm not gonna be here next week, so I'll see you in around 2 weeks. Bye. Thank you.